Soil and Water Conservation Engineering, Unit 3, Bunding. Bunding is a mechanical method for control of soil erosion. When agronomical measures alone are not sufficient, such as mechanical measures should be adapted. Mechanical practices are engineering measures used to control erosion from sloping land surface, and thus land surface modification is done for retaining and safe disposal of runoff water. Bund is an engineering measures of soil conservation used for creating obstruction across the path of the surface runoff to reduce the velocity of flowing water, retain the running of water in the watershed, and thus to help us control soil erosion. In the design of such practices, the basic approach is to increase the time of the stay of runoff water in order to increase the infiltration time of water, to decrease the effect of land slope on runoff velocity by intercepting the slope at several points so that the velocity is less than the critical velocity, to protect the soil from erosion caused by runoff water. The mechanical measures adapted for soil and water conservation are bunding and terracing. Types of bunding. Bunds are simply embankment-like structure constructed across the land slope. Different types of bunds are used for erosion control and moisture conservation in the watershed. When the bunds are constructed along the contour with some minor deviations to adapt to practical situation, they are known as contour bunds. If the bunds are constructed with some slope, they are known as graded bunds. No farming is done on bunds except at some place or some type of stabilization grasses are planted to protect the bund. Type of bunding. The choice of type of bunds depend on the land slope, rainfall, soil type, and purpose of the bund in the area. The contour bunds are recommended for areas with a low annual rainfall, agriculture field with permeable soil, having land slope of less than 6%, while graded bunds are used for safe disposal of excess runoff in area with high rainfall and relatively impervious soil. Design specifications of bunds. First one, types of bund. In types of bund, there are two types, contour and graded bunds, to be constructed depending upon the rainfall and soil condition. Contour bunds are preferred for construction in areas receiving annual rainfall less than 600 mm. And the soil moisture is limiting factor for crop protection. Graded bunds are recommended for heavy and medium rainfall. The grade to be provided to the bund may be vary from 0.2% to 0.3%. Next one, spacing of the bund. The basic principle are adapted for deciding the space of the bund. First one, seepage zone below the upper bund should meet the saturation zone of the lower bund. Next one, the bund should be check the water at a point where the water attain erosive velocity, and the bund should not cause inconvenience to the agriculture operations. Next one, size of the bund. The size of the bund includes its height, top width, a side slope, bottom width. The height of the bund mainly depends upon the slope of the land, spacing of the bunds, maximum intensity of the rainfall accepted in the area. Once the height of the bund is determined, other dimensions of the bunds via base width, top width, side slope are determined using the information on the natural of the soil. Next one, length of the bund. Length of the bund is determined by calculating the horizontal interval of the bund formed. The length of the bund per hectare area of land is given L equal to 10,000 by HI. Earthwork of bunding system includes some earthwork made in main bunds, side bunds, lateral bunds formed in the field. Earthwork of any bund is obtained by multiplying the cross-section area to its total length. The total earthwork can be given by the following equation: ET is equal to EM plus ES plus EI. Whereas ET is equal to total earthwork, EM earthwork of the main bund, ES earthwork of the side bund, EI earthwork of the lateral bund. EM is the cross section area into total length of the bund is equal to 100 S divided by VI, which means cross section area. Next, area loss due to bunding is calculated by multiplying the length of the contour bund per hectare with its base width. A basic formula that will be AL is equal to 10,000 HI divided by I into B, where B is the base width of the bund. Next one is construction of bunds. In construction of bunds, it should start from the ridges and continue down the valley. This will ensure protecting of bunds if rains occurs during the construction. The base width area of the bund should be cleared of the vegetation, and the soil in this area should also be slightly distributed so that the good bunding can be achieved when the bunds is formed over it. Next one, mechanical measures. This method consists of some mechanical obstacles constructed across the prevailing wind to reduce the impact of blowing wind on the soil surface. These obstacles may be fencing walls, stone packing, etc., either in the nature of the semi-permeable or permeable barriers. The semi-permeable barriers are most effective because they create diffusion and aiding effect on the downstream phases. Next, the terrace and bunds are the wind velocity and control the wind erosion to some extent. Generally in practice, two types of mechanical measures are adapted to control the wind erosion. First one, windbreak and shelter. In windbreak, this is a permanent vegetative measure which helps in reducing of wind erosion. It is the most effective vegetation measures used for controlling severe wind erosion. The term windbreak is defined as any type of barrier, either mechanical or vegetative, used for protecting the area like bunding, apartments, orchards or farm sheds, etc. from blowing wind. The windbreak acts as a fencing wall around the affected area, normally constructed by one row or maximum up to two rows across the prevailing wind direction. Next one, shelter bed. Shelter bed is longer barrier than the windbreak. Is installed by using more than two rows, usually at right angle to the direction of prevailing wind. The row of belt can be developed by using shrub trees. It is mainly used for conservation of soil moisture and for protecting of field crop against severe wind erosion. Shelter bed is most effective for reducing the impact of wind movement than the windbreak. Apart from controlling the wind erosion, it provides fuel, reduce evaporation and protect the orchard from hot and cold wind. Next one, sand dune stabilization. A dune is derived from the English word dun, means hilly topographical features. Therefore, a sand dune is a mount, a hill or ridge of the sand that lies behind the part of the beach affected by tides. Sand dune provides sand storage and supply for adjacent beaches. They also protect inland area from storm surge, hurricanes, floodwater, wind wave action that can be damage property. Vegetative measures. This method is most common and preferred worldwide for sand dune stabilization. It is most effective, least expensive, authentically pleasing method which mimics a natural system with a self-repairing provision. However, it have some disadvantages as the plant's established phase is critical. It need irrigation maintenance until self-sustaining system is developed. Most common practice adopted under these are rising of micro windbreaks. It is preferred in those areas where wind velocity is intensive and rainfall is less than 300 mm per year. The rising of windbreak should be completed before the onset of monsoon. Twigs or bush wood are inserted into the soil parallel to one another at about 5-meter spacing. The spacing depends on the intensity of erosive wind velocity. The velocity is more, spacing is less, and vice versa. The fencing of dunes using bush would reduce evaporation loss and enrich the humus content in the soil. Treating the dunes. In this, the micro wind breaks are treated again by planting tree sampling and grasses in the space left. The grass grown in the intersection of plants of windbreak reduce the soil loss from the dune surface significantly. Thank you.